So what are our graduates working on? Like I said, they're working across the board in a whole range of different things. Advanced materials in manufacturing. This is one example. So light metal alloys. At Monash here, we're specialists in light metals. So if you think about the number of vehicles per year and say some nominal amount of magnesium integration to make them lighter, you can see how you could have so much more magnesium used per annum and how things change in the engineering landscape. Some examples that Monash people have been associated with include the development of magnesium engine blocks, which only weigh 14 kilos and have been tried in Volkswagen recently. So you can imagine if you can reduce the weight by 70%, how much cheaper it would be to run, fuel savings, energy savings, less pollution, and a much better planet. Okay, some other examples of advanced materials are ceramifiable plastics, where you might have a plastic cable, okay, that's shielding your wiring, but then in the event of a fire, rather than have things melt and short out, that plastic could turn into a ceramic. Okay, so polymer plus fire equals ceramic, so a phase change. I'll try and move quickly because we're a little bit behind too. So yeah, these are some examples of ceramifiable plastics. Energy. This is another area that we work in, and I'm trying to give you some obscure ones here because I know you cover a lot in the first year. I thought I'll give you a bit of a broadening in this particular presentation. So when you look at the hot desert sun, sunlight provides 1,000 times the energy we need. Sunlight is free. The sun needs no maintenance, for example. So an area that we've been working on quite a lot is solar energy here. Current technology is silicon solar cells. They have quite a lot of problems in terms of cost and difficulty in producing. Okay, so we need simpler, cheaper, lighter alternatives. So here at Monash, what we've done is developed dye-sensitized solar cells where the dye converts sunlight to electron flow. There's a team here that has worked with local companies and used the equipment that prints notes to print flexible solar cells that can be applied in a whole range of different applications. And you see some examples here on the back of a jacket, on a tent, on a tablet, and even a handbag. This is quite a stylish handbag, that's for sure. So biomaterials and tissue engineering, again, materials engineering does mop up biomaterials, which is a real boom area. What are some of the areas in that? There's drug and slow release, there's body implants like knee implants, contact lenses, nanoparticles, so tracers like magnetic particles, heart valves, fixation plates, tissue engineering, polymer dental fillings. And these particular examples, there's people researching in these specific examples here in the department. And these are the sort of people that would be teaching you. Okay, so it's big business and growing. There's a lot of local companies. There's 1 million hip replacements per year, so a lot of local companies involved too that we work with. Okay, so there's no time for more examples, but you can imagine things like biomimicry, self-cleaning, so this lotus leaf effect that I think you learn about in first year. Corrosion is a really important aspect, so durability of materials out there, okay, and also forensics, okay. In what areas do our materials engineers get jobs? They're highly sought after, so we're a small department by comparison to the others, and there's not so many materials engineering departments in Australia. That doesn't reflect the global perspective. So for example, in the United States and in the UK, every school or university will have a materials department, but it just so happens that a lot of the expertise is here at Monash, and so that's a plus for you guys. So our engineers are all highly employable. Most recently, most of them are getting around about 70 plus per year. That's undergraduate. So postgraduate is much higher. A lot of our people, though, however, continue because they really love the research and continue to do postgraduate study in Australia or overseas. They work in a range of areas. Consulting is a very important one too. So about a third of our graduates will get consulting jobs where they work on small projects looking at materials issues in a range of industries. So our biggest employers are companies like ACOM and GHD. They employ about a third of our graduates each year just for consulting. Okay, so who should be doing materials engineering? This is a tough one to answer. So people that are interested in chemistry, maths, biology, medicine or physics, but really anyone that likes a multidisciplinary area, okay? So you work in areas that actually touch on what's done in other departments. It's a very broad range of job prospects, but also materials engineers tend to enjoy what they do. So I guess regardless of which stream you're sort of after, you're going to do well in one that you enjoy. So if you have an inkling and enjoy materials, then I sort of urge you to follow that path. But certainly in speaking to a lot of people that do materials, or all of them, they all really love what they're doing. So that's something important for you guys to think about. So what do we do in second year? Basically, you only get a tiny flavour in first year. So second year builds basic theories and design skills. Because of time, I'm not going to go through it all in a lot of detail. Third year extends the theory and design into more application of materials. So, rather than do pure science, you start to move into engineering, developing materials, understanding materials and structures. At the end of third year, we have a compulsory VAC work component which we get involved and also offer assistance with placements and so forth. But there is that practical aspect. And then in fourth year, again, you guys can find all this information online, but just to tell you, in fourth year, we offer a 2-semester, year-long design project where you can work closely with an academic or with industry. Okay, there's a list of projects that you can select from and do something that's really hands-on. So you get to use all your skills and apply your engineering skills and actually have outcomes prior to graduating. So you get some work experience and you get to do a design project. And then therefore, when you finish, you're highly employable. Okay, so final year project, like I said, it's 2 subjects, so it goes year long. Alright, so materials engineering, the other thing that I wanted to mention is that it's highly research active within the university. So all the people in our department that will be teaching you at least have some PhD students or some research grants. So the material that you're getting is normally fresh and up to date. Come and ask questions, please. So, I know this is a really important decision for you guys because not only does it define the next 3 years, but it probably defines the next 30 or more, depending on what you're going to do. Okay, so if you have any questions throughout the rest of the break or next semester, then come and find any of us academics. Certainly ask some of the students questions later on. But don't be a stranger. So you can find all our contact details on our website. Have a look at our website. There's brochures there, more information there, and certainly come and ask questions. So that's all I had. Thanks, Vicky. But hang on. There's just one more minute. I was just going to get one of the students to say hello because it's customary in materials engineering that we bring some students along, and good for you to hear about people's backgrounds a little bit more. So I'll pass it over to Jess, who some might know from the first year.
Hi. Nice to see everyone's still awake. Thanks to Nick. I'm a student currently doing postgrad with Nick, and I did my undergraduate engineering in materials. I also did a double degree with science. So my undergraduate science was in physiology, which married great into materials because now I'm doing biomaterials. So like you, a few years ago, I was trying to decide on which stream to do, and I picked materials because I'm very interested in science. I love that multidisciplinary field that materials is, but I'd also really say to everyone, ask as many questions as you can. Don't worry if you're confused now, you have no idea. You've got time to think about it, but ask your tutors, ask your demonstrators, ask the lecturers, ask questions so you can make the best informed choice that you can. I'll just say a little bit about the research I'm doing now. So I'm looking at magnesium implants for mostly bone fixation. So put the magnesium implants in there. They provide the support and the natural healing of the body to regrow that bone. The material itself degrades, completely disappears, is healthy, and it's gone. And the problem's solved. So I think that's really cool. So if you've got any questions later, we'll be outside. Good luck.